Hello, everybody. Here is a lesson that goes with your investigation on reflections. So today you're going to figure out mapping notations that result in a pre-image, the original image, being reflected over 4 different lines on the coordinate plane. And then we'll talk about how to visually reflect on the coordinate plane. So I'm sure in like elementary school, you use the word flip instead of reflect. So it's the same thing, it's a flip. So what we're going to do here is, so I've given you 3 ordered pairs, and we are going to use the mapping x comma y arrow x comma negative y. So what that means is your x coordinates are going to stay the same, and then each y coordinate becomes the opposite. And then we'll graph those. So here the pre-image is 1 comma negative 2, so this will become 1 positive 2. So then letter C would be 2, and then opposite of 0 is 0. So let's graph those. Let's change the color. So negative 3, negative 2, negative 3, negative 2 goes here, and we'll call that A prime. And then 1 comma 2 will go here, we'll call that B prime. And then C goes to 0, so it's at the same spot as C. And then you can connect those points. And then what kind of reflection is that? What's the line of reflection, also called the mirror line? So here you could see the mirror line, or the line of reflection, is the x-axis. So each point is equidistant to the line of reflection on the other side. And if it's on the line of reflection, it stays where it is. So that means this mapping notation results in a reflection over the x-axis. By the way, all this that we're doing here, you will see again in Algebra 2 and Pre-Calc. Okay, so for the second one, now we have the mapping x, y, arrow, negative x, y. So we have, negative 3 comma 2, so the x becomes opposite, the y stays the same. Negative 1, negative 2, and then negative 2, 0. So go ahead and graph those points. So 3, 2, negative 1, negative 2, and negative 2, 0. And then connect those, A, B, C, and then look at that reflection. So what's the reflection on here? It's over the y-axis. Number 3, we're looking at x comma y, arrow, y comma x. So what that means is the x coordinate and y coordinate simply switch positions. So negative 3, 2 becomes 2, negative 3. 1, negative 2 becomes negative 2, 1. And then 2, 0 becomes 0, 2. So let's see. So we have 2, negative 3, A prime, negative 2, 1, B prime, and then 0, 2 becomes C prime. And then we're going to connect those. And this one can be a little tricky to see, but I'm going to tell you it's one of the diagonal lines. So let's change the color here. So here you can see that it becomes the line y equals x. So the points become equidistant. The corresponding points are equidistant to the mirror line. Might be kind of hard to see on this one. So that's a reflection over y equals x. And then we'll go to number 4. So here, the x coordinate becomes the opposite of the y coordinate, and the y coordinate becomes the opposite of the x coordinate. So negative 3, 2. So let's say the 2 is a negative, and then 3. So negative 2, 3. Then 2, negative 1. And then 0, negative 2. So let's graph those. So negative 2, 3. Two, negative 1. Whoops, that should be A prime. B prime. And then 0, negative 2 will be C prime. So let's see. So we have the A and the A prime, C and the C prime. Let me change the color again. So A and A prime, C and C prime, B and B prime. So we want the line that divides those segments in half. Or what kind of line is that? We'll talk about this in a couple days. But what kind of line is that as it relates to these segments that connect corresponding points? If you said perpendicular bisector, you would be correct. So we'll talk about that another day, but that's an important piece. The mirror line, or the line of reflection, is the perpendicular bisector of the segments connecting corresponding vertices. So what line did we just draw? That is y equals negative x. It has a slope of negative 1, and the y-intercept is 0. So let's summarize those 4 mapping notations. So if it reflects over the x-axis, it's x comma y, arrow, and then if it flips over the x, that means the y-coordinate becomes the opposite and the x stays the same. And you can use this for flipping triangles, quadrilaterals, single points. Actually, every point on these figures would follow this same mapping notation. And the same will go for graphs. When in Algebra 2, you're going to actually flip graphs like y equals x squared and so forth. Okay, y-axis. So xy, arrow. This is the full mapping notation that I would ask you to write out. And then that becomes negative x comma y. Y equals x is xy, arrow, yx. And then y equals negative x is xy, arrow, negative y, negative x. So that would be good to have in your notes. And as you're probably aware, our tests have now become open note tests. So this would be good to have handy. So now the next question has you take an ordered pair and then just reflect that one ordered pair over the four lines that we talked about. So you have the x-axis is following x negative y. So that means 5 stays the same, negative 6 becomes the opposite. Now the y-axis. So again, basically you're just plugging the 5, negative 6 in for x and y into the mapping. So now y-axis reflection would be negative 5, negative 6. And then y equals x, you just change the x and the y. So the 5, negative 6 becomes negative 6, 5. And then y equals negative x becomes 6, negative 5. And if you want the visual, put this on graph paper. And you'll see that you could actually do this just on graph paper if you forget what the mapping notations are. So 3 comma 0 becomes negative 3, sorry, let me erase that. So 3, 0 becomes 3, negative 0, which is 3, 0. And then for the y-axis, reflection becomes negative 3, 0. Y equals x becomes 0, 3. And then y equals negative x is 0, negative 3. And then we can go ahead and finish the rest. So then it will become negative 4, 1, 4, negative 1, negative 1, negative 4, and then 1, 4. And then go ahead and finish. Negative 3, 5 becomes negative 3, negative 5, 3, 5, 5, negative 3, and lastly, negative 5, 3. All right, and then let's finish this investigation. So questions you might see on your homework are, so if you have a reflection across y equals negative 1, you're going to draw, so what is y equals negative 1? So that's a line that has a slope of 0, right? This is y equals 0x minus 1. And then the y-intercept is negative 1. So it's a horizontal line at negative 1. So there's the mirror line. And then let's change the color. And now we're going to reflect over y equals negative 1. Now, these are not the special mapping notations that we learned. So you're going to visually reflect it. So here the g is 2 units away from the line. So then the g prime will be 2 units on the other side. H is 3 units away underneath, so it'll be 3 units above H prime. And then F is 2 away, so 2 below. And then connect your 3 points. Oh, that's kind of a mess. Let's change the color there. And there it is. There's the reflection over the line, y equals negative 1. Now, x equals 3 for the next one. That is a vertical line. Remember, x equals means the x stays constant at 3 while the y's change. That has undefined slope. So now let's reflect this triangle. So here the j is 1 unit away, so j prime is 1 unit on the other side. K is 2 units, so it becomes 2 units on the other side, and then the I is 2 units. So essentially the K and the I just swapped places. And there's the image, JKI prime, right there. So your homework will be the reflections worksheet that is on Google Classroom. When you're done, you will take a picture and upload it when you're finished. If your printer is not available, you can just write the problems on paper or graph paper and upload the picture of that and hand in. As always, if you have any questions, please email me, and have a wonderful day.